Hello my dear students, I warmly welcome you to CR Digital Classes. So now in this lecture, we are going to discussing the problem based on the QR Factorization Theorem. Okay. First of all, observe the question. Given capital A is equal to 1, 2, 5, minus 1, 1, minus 4, 1, 4, minus 3, 1, minus 4, 7, 1, 2, 1. Okay. So this is a rectangular matrix. There are total 5 rows and 3 columns. Okay, 5 by 3 matrix capital A. Then find an orthogonal basis for the column space of capital A. Okay, for this matrix we have to find the orthogonal basis for column space of capital A and also find the QR factorization of capital A. Okay, so we have to find the orthogonal basis for column space of A and QR factorization. So these types of problems are very important for the long answer purpose. Okay, so observe carefully. Process is very easy. Already on the Telangana process. So the Gram-Schmidt process. To find that orthogonal basis, to find that orthogonal basis. So whenever we can use that the Gram-Schmidt process. So therefore given matrix capital A is equal to, that is a given 5 by 3 matrix. Let the basis be, basis we can take columns of capital A, we can take the basis. Okay, columns of capital, whenever they give in the matrix format, even though in Gram-Schmidt process, if they give the matrix, the basic we have to take x1, x2, x3 as columns of capital A as the basis. Okay, so it is only basis, it is not an orthogonal basis, just a basis. Okay, so therefore the basis capital B, let the basis be x1 is equal to first column. Okay, this first column of capital A we can take it as small x1. Next to x2, x2 is equal to second column, 2, 1, 4, minus 4, 2 is the x2, second vector. Third column of capital A we can take it as a third vector in that basis x3. Okay, so that is the selection of the basis from the given matrix capital A. After selection of basis, now by Gram-Schmidt process we have to find the orthogonal basis. So we can start the process. Step 1. Let step 1 is equal to V1 equal to x1. That is the formula, you know very well. So V1 is equal to, we can take directly x1 as the first orthogonal vector trivially. So therefore W is equal to span of x1, that is equal to span of V1. Ante ఈ V1 అనే వెక్టర్ వల్ల ఫామ్ అయిన సబ్ స్పేస్ ఏంటి W1 అనేది. యాక్చువల్ గా ఒరిజినల్ సబ్ స్పేస్ ఏంటి, మనం ఒరిజినల్ సబ్ స్పేస్ ఇస్ ద W. దట్ W is generated by these three vectors, but for only with respect to x1 we got V1 value, and V1 వల్ల మనకి ఏంటంటే W1 అనే సబ్ స్పేస్ జనరేట్ అవుతుంది. సో therefore W1 is generated by x1 and W1 is generated by V1. Span of x1 is equal to span of V1. Next step 2. Let V2 be the vector produced by subtracting from x2 its projection onto the subspace W1. So the formula for the second orthogonal vector is V2. V2 is equal to x2 minus, this is the formula for the projection of x2 onto the subspace W1. Projection of x2 onto the subspace W1. So here we can find the values, numerator value x2 into V1 is equal to, substitute that x2 matrix and V1 matrix, then multiply them, you will get that value is equal to minus 5. Next V1 into V1, substitute the V1 value and V1 value again, then you can multiply them, you will get that value is also equal to 5. Okay, so now substitute the corresponding values in V2, then we can obtain that V2 is equal to x2 minus, okay, that denominator value is plus 5, numerator value is minus 5, substitute them and simplify, then you will get x2 plus V1. And now substitute that x2 second vector from the basis and first orthogonal vector V1. So add both column matrices, then you will get the resultant second orthogonal vector, that is V suffix 2 is equal to 303 minus 3. Okay, so here V suffix 2 is the component of x2 and this V suffix 2 is orthogonal to the first vector x1. Okay, and V1 V2 is an orthogonal basis for the subspace W2 spanned by x1 and x2. This total theory part you know very well. And next we can go to the step 3. Step 3 means let capital V3 be the vector produced by subtracting from x3 its projection onto the subspace W2. Okay, we use the orthogonal basis V1 V2 to compute this projection on W2. Okay, so therefore V suffix 3 is equal to x3 minus this one. This value is the projection of x3 onto subspace V1. Okay, this total value is the projection of x3 onto the subspace V2, a vector V2 or subspace W2 అని రాసుకోవచ్చు. ఓకే, subspace W2 ఇక్కడ కూడా మీరు subspace ఏం రాసుకోవచ్చు అంటే W2 అని రాసుకోవచ్చు. Here x3 into V1 is equal to so x3 value, that is the third vector, and V1 value, if you multiply them we will get the value which is equal to 20. And already V1 we have. Okay, and next value is x3 into V2. Substitute that x3 value and V2 value, then if you multiply them you will get minus 12. Next to V2 into V2, so V2 value that is the plus 36. Then substitute the corresponding above values in V3, then we get that V suffix 3 is equal to x3 minus 25 by 5 into V1 minus 12 by 36 into V2. So therefore V suffix 3 is equal to, just ఇక్కడ మనకు obtained values అన్ని ఇవే మనం. సో ప్రీవియస్ గా మనం ఇక్కడ x3 v2 ఆ వాల్యూస్ అన్ని ఏంటంటే ఇక్కడ జస్ట్ సబ్స్టిట్యూట్ చేసాం in the equation of V suffix 3. So after substituting 5 1s are 5 4s are, okay, so 12 1s are 12 3s are x3 minus 4v1 plus 1 by 3 into v2. So therefore, so you will get in this format by substituting the corresponding values x3 value, and if you multiply that v1 value with 4 then you will get, and v2 value if you divide with 3 then you will get in this format. So therefore v3 is equal to resultantly 2022 minus 2, that is a V suffix 3 value. Here the orthogonal basis for the column space is v1 v2 v3. Column space is nothing but columns of capital A. That columns of capital A is basis x1 x2 x3. So therefore this is the orthogonal basis. This one is the v1 and v2 and v3. Okay, there is no rational fractions in the entries of v1 v2 v3. So that's why we are not doing the scaling of the vector process. So if any rational factor is there, then we can scale the vectors with respect to the denominator value. Now QR factorization of capital A. So QR factorization of capital A, let u1 u2 up to some u suffix 3 be the orthonormal basis for the vectors v1 v2 up to some v1 v2 v3 respectively. Then the matrix Q is we can given by u1 u2 u3. Here we got orthogonal basis amma. Orthogonal basis ni now we convert into orthonormal basis. Okay, how we can convert? By taking the normalization process. Okay, so this total process is called normalize amma. So by normalizing these vectors v1 v2 v3, normalizing this orthogonal basis, then first vector u suffix 1 is equal to, formula is 1 by norm v1 into v1. So u suffix 1 is equal to 1 by norm v1 is nothing but the square root of the squares of the sum of the entries in v1. Okay, so these all are the entries, 1 minus 1 minus 1 1 1 are the entries in v1. So what అనేది మనం స్క్వేర్ చేస్తాం. So and into the vector v1. So మీరు దాన్ని సింప్లిఫై చేసుకుంటే 1 by root 5 into that vector. So if you divide with 1 by root 2 if you divide with 1 by root 5, then u suffix 1 is equal to 1 by root 5 minus 1 by root 5 minus 1 by root 5 1 by root 5 1 by root 5. That is the total vector of u suffix 1. That is the orthonormal column of capital Q. Next second vector u suffix 2 is equal to, formula is 1 by norm v suffix 2 into v suffix 2. So therefore, okay, so u suffix 2 is equal to 1 by, so these are the length of the vector v2. Already we have vector v2 values from the this condition. Okay, so these are the values for the vector v2. For those values we are writing in the formula. Okay, so norm and that v2. So if you simplify them, 1 by 6 into 303 minus 3. So therefore, if you divide with 1 by 6, then you will get 1 by 2, 0, 1 by 2 minus 1 by 2, 1 by 2. Next, third vector u suffix 3 corresponding to the vector v suffix 3 by norm v suffix 3. So these are the formulas, and simplify them. You will get u suffix 3 is equal to 1 by 2, 0, 1 by 2, 1 by 2 minus 1 by 2. After getting those values, then the matrix Q is, we can form by columns of orthonormal values. Okay, so u suffix 1, u suffix 2, u suffix 3. Okay, u suffix 1 is this total column, u suffix 2 and u suffix 3. Those all values we are writing columns of capital U. So therefore capital Q is equal to, it is a m by n matrix అని చెప్పుకున్నాం కదా మనం QR factorization లో. It is also a 5 by 3 matrix. 5 rows are there, 3 columns. Now that is a Q matrix వచ్చింది కదా. To find the QR factorization, so we need to find that the capital R. So okay, the upper triangular matrix capital R is equal to Q transpose into capital A. Q transpose into capital A. So therefore ఈ ఫార్ములా మనం డిరైవ్ చేసుకోవచ్చు డైరెక్ట్ ఫ్రమ్ దిస్ ఈక్వేషన్ అమ్మ. A is equal to Q into R నుంచి we can derive that formula. So therefore capital R is equal to Q transpose into A. So therefore capital R is equal to, we can write that value as Q transpose is there. Q is the 5 by 3 matrix. If you apply the transpose, it will become 3 by 5. Rows will become columns, column will become rows, and capital A will be as it is. Okay, so therefore this one is the Q transpose, this one is the A. So therefore Q transpose into A. Now multiply. Here A is the 5 by 3 matrix summa. So we can apply the multiplication for them. So with the first row we can multiply these 3 columns. With the second row we can multiply the same 3 columns. With the third row we can multiply the same 3 columns of capital A. Okay. So by proceeding in this format, we will get the values in this format amma. Okay. So the total multiplication you can observe easily. That process is very easy, multiplication of those two matrices. After multiplying, then you will get in this format capital R is equal to 5 by root 5 minus 5 by root 5, 25 root 5, okay, 0, 6 minus 2, 0, 0, 4. Okay, so therefore capital R is equal to root 5 minus root 5, 4 root 5, 0, 6 minus 2, 0, 0, 4. Okay, so by simplifying that matrix, resultantly we can get this matrix. Here you can observe carefully. After getting that capital R matrix, this capital R is an, first of all, square matrix. Square matrix means it is a 3 by 3 matrix, and here you can see capital R is upper triangular. Upper triangular means these values will become 0, then this value is the upper triangular. Okay, that value is the upper triangular. Upper triangular inversible matrix. For this matrix, inverse is also exist. We can find inverse. Why? Because the determinant of this matrix is not is equal to 0. It is a non-singular matrix, so easily we can find the inverse of this matrix. So therefore here capital R is upper triangular inversible matrix with positive entries. Positive entries means root 5 plus 6 plus 4. These all are the positive entries on its diagonal. Positive entries on its diagonal. So therefore capital R is a 3 by 3 upper triangular inversible matrix with positive entries on its main diagonal. So in this format also we can find the QR factorization of capital A. Here we got capital Q amma. So ఇక్కడ మీరు అబ్జర్వ్ చేసుకుంటే capital Q వచ్చింది కదా ఈ matrix ని, and here we got capital R ఈ matrix ని. If you multiply both matrices, that means here Q we have 5 by 3 order into capital R is 3 by 3 order. If you multiply these 3 matrices, again you will get 5 by 3 matrix capital A. Okay, again you will get capital A 5 by 3 matrices. Okay, so that is the QR factorization. After completion of the total solution in examination, if you have any free time, so you can do this verification process. Why? Because for the confirmation to get the full marks, so if you have any extra time in the examination, do the multiplication for that Q and R. Okay, so therefore in this format we can find the QR factorization for any matrix capital A, and we can also find orthogonal basis for any matrix by using the Gram-Schmidt process and the theorem QR factorization theorem. Okay, ఇప్పుడు మీకు అర్థమైంది కదా ఈజీగా. జస్ట్ నార్మలైజింగ్ ఆఫ్టర్ ఫైండింగ్ దట్ ఆర్థోగోనల్ బేసిస్ టు ఫైండ్ దట్ ద QR factorization of capital A, just we are doing the process normalizing. In that normalizing, ఈ ఫార్ములాస్ మీరు హైలైట్ చేసుకోవాలి. యూ సఫిక్స్ 1 ఫార్ములా, యూ సఫిక్స్ 2 ఫార్ములా అండ్ యూ సఫిక్స్ 3 ఫార్ములా. ఈ ఫార్ములాస్ మీకు ఐడియా ఉండి ఆ వచ్చిన వెక్టార్స్ మీరు ఫైండ్ అవుట్ చేశారనుకోండి, ఇట్ విల్ బి వెరీ ఈజీ అన్నమాట. హియర్ యూ కెన్ అబ్జర్వ్ వన్ మోర్ థింగ్ అమ్మా. దట్ వన్ మోర్ థింగ్ ఈస్, హియర్ వీ గాట్ యూ సఫిక్స్ 1 వాల్యూ కదా. ఈ యూ సఫిక్స్ 1 వాల్యూకి ఇఫ్ యూ అప్లై దట్ నామ్, ఇఫ్ యూ అప్లై దట్ అగైన్ నామ్, then you will get amma, okay, 5 by 5, that value is equal to 1. That means here u suffix 1 is a unit vector. U suffix 1 is a unit vector. And similarly u suffix 2, okay, the formula is the resultant vector is u suffix 2 is this one. For this also you can apply the norm u suffix 2. Therefore you will get under root of 4 by 4 amma. That means 1 by 2 whole square plus 1 by 2 whole square plus minus 1 by 2 whole square plus minus 1 by 2 whole square. ఈ ఫార్మాట్లో మీరు చేశారనుకోండి, సో మీరు ఈ నామ్ u/2 కూడా మీకు ఏమొస్తుందంటే 1 వస్తుంది. సిమిలర్లీ నామ్ u3 వాల్యూ ఇస్ ఆల్సో లెంత్ ఆఫ్ దిస్ u3 is equal to also you will get 1. That means under root of 1 by 2 whole square plus 0 square plus 1 by 2 whole square plus 1 by 2 whole square plus minus 1 by 2 whole square. సో మీరు ఇవన్నీ చేశారనుకోండి, సో 4 by 4 వస్తుంది మీకు. 4 క్యాన్సిల్ అయిపోతే 1 వస్తుంది. సో దేర్ఫోర్ నామ్ 3 అంటే రిజల్టెంట్ గా నాట్ v1 v2 v3 అమ్మ. v1 v2 v3 లో నాట్ యూనిట్ వెక్టార్స్. u1 u2 u3 ఆర్ ద యూనిట్ వెక్టార్స్. ఓకే, దీస్ యూనిట్ వెక్టార్స్ ఫామ్ అయినప్పుడే మనం ఏమని చెప్తామంటే దట్ సెట్ ఈస్ కాల్డ్ ఆర్థోనార్మల్ బేసిస్. ఓకే, so that unit vector set is called orthonormal basis. Those orthonormal columns of those orthonormal vectors are the columns of Q. Okay, so that is the QR factorization theorem కూడా మనం అదే డిస్కస్ చేసాం. క్యాపిటల్ Q లో ఉన్న కాలమ్స్ అన్ని మనకి ఎలా ఉంటాయంటే, ఓకే, నెక్స్ట్ స్లైడ్. ఇక్కడ మీకు క్యాపిటల్ Q అనే మ్యాట్రిక్స్ ఉంది కదా. ఈ ఫస్ట్ కాలం ఆర్థోనార్మల్ కాలం, దిస్ వన్ ఇస్ ద ఆర్థోనార్మల్ కాలం, దిస్ వన్ ఇస్ ద ఆర్థోనార్మల్ కాలం. సో ఇవన్నీ ఆర్థోనార్మల్ కాలమ్స్ అన్నమాట. ఓకే, సో ఇక్కడ మీకు మెయిన్ డయాగ్నల్ లో ఉన్న ఎలిమెంట్స్ అన్ని పాజిటివ్ ఎలిమెంట్స్ and it is an upper triangular matrix. Not only for this matrix amma, you have more than you have some more problems in your linear algebra material. Okay, so if you do practice any question, you will get the same procedure in this format only. Based on the QR factorization theorem, every year one long question will come, and based on the Gram-Schmidt process, every year one long question will come, either procedure or problem. Okay, definitely. So this is the total explanation of this problem based on the Gram-Schmidt process and QR factorization. Okay, so this is the total explanation of this lecture. I hope you understood this lecture very well. Okay, with this lecture, so this total videos of linear algebra completed. Dear students, make a perfect to practice, prepare well. Until bye. This is K. Veeres signing off CR Digital Classes. Thank you.